This embryo is only 6 weeks old, and yet the epithelium over its mandible is already thickening in preparation for what's about to happen. As it grows thicker, the epithelium creates an island of cells, which is the origin of the new tooth. This is the dental lamina, and its remarkable potential is starting to unfold. As we get closer, we can see other key players in the formation of our dentition. Meckel's cartilage provides support for the developing tissues, and the blood vessels that help shape the embryonic teeth are present. By now, the lamina has grown into a bud. The epithelial cells haven't changed much, but as the bud grows, it starts to bend into a dome in response to pressure from the blood vessels, and the mesenchymal cells underneath condense. At this point, we can already identify the cells that will form the tissues of the mature tooth. The enamel organ is made of cells from the epithelial cap, and it will generate the enamel of the tooth. The condensed mesenchymal cells will form the dentin and the pulp, and they are called the dental papilla. The dental follicle will develop from the remaining condensed mesenchyme. And all of these cells together are known as the tooth germ. So far, we've seen the bud and cap stage of tooth development. The third, and most dramatic, is the bell stage. As the tooth germ begins to grow, the cells differentiate. The stellate reticulum is now obvious. Made up of star-shaped cells pushed apart by fluid pressure, it separates the inner and outer enamel epithelium. Just visible is a flattened area of cells called the stratum intermedium. We can also see the juncture where the inner and outer enamel epithelium meet. This cervical loop is important in tooth formation, as we'll discover soon. By the time the tooth bud pinches off from the dental lamina at the end of the bell stage, the inner enamel epithelium has folded to form the shape of the future crown. With a scaffold to work on, the masons of the tooth world go to work. The cells of the inner epithelium have elongated into ameloblasts, and the neighboring cells in the dental papilla respond by changing into odontoblasts. Now they move toward the center of the papilla, leaving a thin tube of cytoplasm and a layer of dentin. And now, the ameloblasts start to move, leaving behind the hardest tissue of all, enamel. The resulting rock-hard crown of enamel and dentin is a miraculous feat of cellular engineering, but the engineers haven't finished yet. An extension of the cervical loop forms as a collar called Hertwig's epithelial root sheath that causes other odontoblasts to start forming the dentin of the root. At the same time, the whole tooth starts to move like a biological rocket taking off, and a perfectly formed deciduous incisor is delivered into the oral cavity. Its new owner, of course, is delighted.